Okay, students, we are going to be doing some antiderivatives. This is section 4.1. All right, so by now you have learned that the integral or antiderivative is just the opposite of taking a derivative. These are also called differential equations. So in number 1, the question says, find the general solution of the differential equation and check the result by differentiation. Use C for the constant of integration. Okay, so when we integrate dy over dt, we're just integrating both sides. All right, so the integral of dy is just going to be y. And you can actually, take this dt and multiply both sides by it, and it's going to move up here to the back. So we're integrating 15t squared dt. And that just tells you, with what variable you're integrating with respect to. So we're taking the integral of 15t squared with respect to t. Okay, and so we're going to use our power rule, which is to add 1 and divide by the new exponent. So 2 plus 1 is 3. So we would have 15t cubed divided by 3, which is 5t cubed. And then don't forget we need to add our constant. And like they said in the directions, you can check this by differentiating. So if we checked it, we would multiply 3 times 5, which is 15. And then subtract 1, so 15t squared. And the derivative of a constant is 0. And so, of course, that would be your dy dt. So it's very easy to check these. Okay, so let me type this in. Whoops, I'm putting in the wrong thing. I'm putting in the original. So 5t cubed plus c. All right, so that's correct. Next problem. So it's another one. We're finding the general solution of a differential equation and check the result by differentiation. You see for the constant of integration. So we're integrating 7x to the 7a dx. I'm going to go ahead and put my dx over there. All right, sorry my 8's very much a blob. All right, so we're going to add 1 to our exponent. So that 1 is 8 over 8. 7/8 plus 8/8 would be 15 over 8. And then when you divide by that new exponent, you're multiplying by the reciprocal. So in the front, I'm just going to multiply by 8 over 15. Don't forget the plus c. Okay, so to clean this up, 8 times 7 is 56. So 56 over 15, x to the 15 over 8 plus c. Make sure that you always go down before you put that plus c. Otherwise, it's going to be up there in the exponent. Okay, so that's correct. All right, the next one, looks like we have a step-by-step problem where you have to fill in several parts. Okay, so you have your original integral, which is 6 over x to the 5th dx, and we're going to rewrite that. So they have a box in the front, if you notice this, and then there's the integral symbol, and then there's x, and then you have a box for the exponent. Okay, so what can we put in the front of the integral symbol? We can put a 6. You don't have to do that, but on this problem you do. Okay, so you can always move your constant or your coefficient to the front of the integral symbol. And then our exponent is going to be to the -5 because we're going to bring that x to the 5th to the numerator. So that's going to make the exponent become negative. So now our problem is going to be 6. What we're integrating is 6x to the -5. Well, sorry, what we're doing now, in this box is we're going to actually integrate it, and to do that we need to add 1. So let me just write it out right here. Okay, so we're going to have 6 times x to the -4. We get that by adding 1 to the -5, and then we need to divide that by the -4. And then you have your plus c out here. All right, and then simplify that. So think 6 over -4 reduces to -3 over 2. And then we have x to the -4. Should let you leave it like that, or if it's wrong, then we'll put in -3 over 2 x to the 4th. Turn it into a positive exponent. But I'm pretty sure they'll let us leave it negative, so we'll check and see. All right, so the first box is 6, and then it's to the -5, and then this is 6x to the -4 divided by -4, and then cleaned up we have -3 over x, forgot my 2, 2x to the -4. Oops, sorry. On the bottom it'll be a positive. I just want to see if they will let us put in the negative exponent. They should. Webassign is generally pretty lenient with putting answers in. All right, let me clear this and then check. But if not, we'll just fix it. No big deal. Yeah, okay, they do want us to fix it. So, okay, I'm just going to go ahead and put in the fraction box. So -3 over 2. So our x would be on the bottom, x to the +4. My shift 6 wasn't working for some reason. All right, let's see if that's going to work. Well, it would have if my 4 was an exponent. Okay, let's try that again. All right. Could have sworn I've already done that. Okay. I don't know what they're asking for here. Okay, let's try this again. All right, so 6x to the -4 divided by -4. We don't want to leave a negative in the denominator, 6 over 4 reduces to 3 over 2, so that would be negative 3/2. And if we put our x to the negative 4 into the denominator, it would become x to the positive 4. Well, okay, students, there you go. I forgot my plus C. How many times have I told students to don't forget your plus C? And I did it. So anyway, as you can see, I put the plus C, and we're all good now. So you can leave the exponent negative. I'm sure it would have taken it either way if I had just remembered my plus C. So sorry about that. That problem had me flustered for a minute. I knew my integration was right. All right, so the next one we are integrating 6 minus x dx. You can separate it into two different integrals, but you really don't have to. So just integrate your constant 6. So that means you would just put an x on it, because think the derivative of 6x would give you back 6. And then x to the first, so that would be minus x squared, adding 1 to the 1, divided by 2, plus c. I'm not going to forget that again. All right. So that if you're watching this, hopefully you will never forget to put your plus c on these indefinite integrals. Okay. All right, so number 5, we have integrate x cubed minus 10x minus 8 with respect to x. So the integral of x cubed would be x to the 4th over 4 minus 10x squared over 2 minus 8x plus c. Okay, now you can also write that as 1/4 x to the 4th if you prefer. And then, of course, 10 over 2 is 5, so 5x squared minus 8x plus c. I kind of like the 1/4 x to the 4th a little better than x to the 4th over 4 for some reason. All right, so I'm going to go down and check that. And it is correct. So we have two more problems. The integral of the square root of x plus 1 over 6 square root of x dx. We need to rewrite the square root of x as x to the 1/2, and then 1 over 6 square root of x would be 1/6 x to the negative 1/2 with respect to x. Okay, so when we add 1 to the 1/2, a half plus 2/2 is 3/2, multiply by the reciprocal, so that would be 2/3 x to the 3/2. Okay, when we add 1 to the negative 1/2, we're going to have x to the negative 1/2 plus 2/2, which gives you positive 1/2. So x to the 1/2 divided by 1/2, which is the same as multiplying by 2. So that would be 1/6 times 2, and then we'll have our plus c. So cleaning that up a little, 2/3 x to the 3/2, and then 1/6 times 2 is 1/3 x to the 1/2 plus c. And you don't really need to, transfer those back into radicals. You can always just leave these as rational exponents. All right. All right, so our last problem is a differential equation that also gives us an initial condition. F of 3 is equal to 9. Okay, so if you noticed when you were going through the notes for this section, when they give you a function value like that, then that means you can actually solve for the constant. So they're giving us f prime of s, so when we integrate f prime of s, you're integrating the derivative. So those are like inverses, so they're going to cancel each other out. So we're integrating 12s minus 4s cubed with respect to s. So the integral of f prime will just give us back f of s. Okay, the integral of 12s would be 12s squared divided by 2. And then the integral of negative 4s cubed is negative 4s to the 4th divided by 4. Okay, plus c. All right, so we know that this 12 over 2 is going to reduce. So that's just 6s squared, and then 4 over 4 reduces to 1, so that would be just s to the 4th plus c. Okay, so now we're going to substitute this initial condition that f of 3 is equal to 9. So we're going to plug in 9 in place of our f of s, and we're plugging in 3 in place of our s, and we're solving for c. So 6 times 9 would be 54, minus, and then 3 to the 4th is 81, plus c. So let's see, 54 minus 81 is going to be negative 27. So we would add 27 to both sides to solve for C. 9 plus 27 is 36. So when we actually type our answer in, we're going to replace that C with the 36. So since I'm kind of out of room, I'm just going to go ahead and go to my answer box and type that in. All right, so that would be 6s squared minus f to the 4th plus our c, which we found that to be 36, if my math was correct. I was solving that in my head, so. Okay, great. All right, I hope that helped, and I apologize for the little mess up earlier. At least that, goes to show y'all that even teachers make mistakes. See y'all next time.